All right, today we're going to be filling in this function family cheat sheet. So this is a bunch of function families that we're going to be referencing throughout the year. So as you graph these points with me, you're going to want to make sure that you graph these function families accurately with points in the correct place. So this first problem right here, we have y equals x, and the first thing we want to know is the function family this equation belongs to. If you already know, you can go ahead and write it down, but if you don't, let's graph it and then we can see what the graph looks like. So when you graph this, if you already remember how to graph the equation y equals x, you just go ahead and do that. But if you don't, remember you can get any graph by making a table. So I'm just going to make a table. And when you make a table, you get to choose your x values. I'm going to use my personal favorite x values, which are -2, -1, 0, 1, and 2. Now, if I plug each of these values into the equation, my first x value is -2. So if I put -2 in for x, well, notice this equation says that y equals x. So if x is -2, then y will also be -2 because x and y are equal. Well, the same is true for -1. If x is -1, then y is also -1 because they have to be equal. The same will be true for 0. If x is 1, then my y is 1, and if x is 2, then my y is also 2. So now I'm going to go ahead and graph these points. I have the point -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. Now, if I connect these dots, you might notice that they're just going to go ahead and give me a straight line that looks like this. Since this graph creates a line, the name of the function family is linear. Hopefully you can hear the word line in the word linear. So that's that function family. If we look at problem 2, we have y equals, these two bars right here, remember, are called absolute value. So this equation says that y equals the absolute value of x, which means, as you might guess, the name of this function family is the absolute value family. Now, if you already know what the absolute value parent function looks like, you can go ahead and graph it. But if you don't, then again, I'm going to go ahead and just make a table. And once again, I'm going to choose my favorite x values, which are -2, -1, 0, 1, and 2. Now, if I put -2 in for x, my equation will be y equals the absolute value of -2. Well, remember that absolute value means what is the distance from 0? In other words, how far from 0 is -2? Well, -2 is 2 places away from 0. And because this is a distance, it's going to be positive because distances are always positive. So the key thing here is that when we pull a number out of absolute values, it will always, always be the positive version of that number because it's a distance. That means if I put -1 into the equation, I'll have that y equals the absolute value of -1. Well, -1 is 1 place away from 0. And it's going to be positive because it's a difference, a distance. Now 0, how far is 0 from 0? Well, it's not, so it's going to be 0 away from 0. 1 is 1 place away from 0, and 2 is 2 places away from 0. So if I graph these points, I have the point -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Once again, if I connect these dots, then I'm going to get something that looks like this. Notice how the absolute value graph gives us this V shape. All right, if we look at problem 3, we have that y equals x squared. Now, hopefully you remember graphing these last year. If you remember what this parent function looks like, you can go ahead and just graph it. But if you don't, then once again, I'm going to go ahead and make a table. And I'm going to choose, again, my favorite x numbers, which are -2, -1, 0, 1, and 2. Now, if I plug -2 into this equation, I'll have that y equals -2 squared. Well, remember that second power means -2 times -2. A negative times a negative is a positive, and 2 times 2 is 4. So my y value will be 4. If I put -1 into the equation, I have y equals -1 squared. Well, -1 times -1 is +1. If I plug in 0, 0 times 0 is 0, 1 times 1 is 1, and 2 times 2 is 4, and there's my table. So if I graph these points, I have the point -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And if I connect these points, I get this shape right here. Now, this shape has a name. Hopefully you remember from last year that we call this shape a parabola. But even though the shape is called a parabola, that's not the name of the function family. We call this the quadratic family. All right, well then if we look at the next problem, number 4, we have that y equals the square root of x. And as you might guess, that means that this function family is called the square root family. So once again, to graph it, I'm going to go ahead and make a table, but I notice that in this case, I'm taking my x values and finding their square roots. Since I don't know the square root of -2, I'm not going to put it on my table. I could put on the square root of -1, but as you may recall from last year, if we try to find the square root of a negative number, that actually gives us an imaginary answer. The square root of -1 is actually equal to 1i. Now there's not a way to graph imaginary numbers here on our graph, so I'm not going to put negatives on my table because I don't want to deal with those imaginary numbers. So instead, I'm going to start at 0, and then 1, because I know the square root of 1. I don't know the square root of 2, so I'm going to leave it off. Same problem with 3, I don't know its square root, so I'm going to leave that off. But I do know the square root of 4. And I don't know the square roots of 5, 6, 7, or 8, but I do know the square root of 9. So I'm going to choose these numbers for my table because I know their square roots. So, for example, my first x value is 0. If I want the square root of 0, remember that equals 0 because 0 times 0 equals 0. Okay, the same thing with 1. If I take the square root of 1, it's going to equal 1 because 1 times 1 equals 1. Okay, how about 4? The square root of 4 is actually 2 because 2 times 2 equals 4. And same story with 9. The square root of 9 is 3 because 3 times 3 is 9. So if I graph these points, I have the point 0, 0, 1, 1, 4, 2, and 9, 3. And if I connect these points, I get a graph that looks like this. Now, if you look at the quadratic and the square root functions, you might notice a similarity in their shapes. They actually look very similar, particularly if I finish out the square root on the other side. Can you see how the square root function is the parabola kind of turned on its side? Because these two functions have this relationship, we actually call them inverse functions. And we are going to be learning more about inverse functions as the year goes on. But these two, the quadratic and square root families, are inverse families. All right, let's go ahead and look at graph number 5, which is y equals x to the third power, or x cubed. And because we would read this as x cubed, we call this, oops, wrong color, sorry. We call this the cubic family. Now once again, to get the graph, I'm going to make a table. And again, I'm going to choose my favorite numbers, -2, -1, 0, 1, and 2. If I put -2 into this equation, I'll have that y equals -2 to the third power. Well, remember that third power just means multiply -2 3 times. So we have -2 times -2 times -2. Well, -2 times -2 is +4. And if I multiply that by -2, I get -8. So when x is -2, y is -8. If I plug in -1, then I'll have that y equals -1 to the third power, which is the same thing as -1 times -1 times -1. Well, -1 times -1 is +1. Multiply that by -1 and we get -1. Okay, 0 to the third power is going to be 0 because of course 0 times 0 times 0 is 0. 1 to the third power is 1 because 1 times 1 times 1 is 1. And 2 to the third power, well, that's the same thing as 2 times 2 times 2. 2 times 2 is 4. And if I times that by 2 again, I get 8. So 2 to the third power is 8. If I graph these points, I have the point -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. And I get a graph that looks kind of like this. Okay, so our cubic function gives us kind of this squiggly line. All right, last but not least, graph number 6, we have y equals the third root of x, or we can also say it's the cube root of x. And because we call it the cube root, this is the cube root family. Now, once again, in order to get the graph, I'm going to make a table. But this time, I notice that I'm taking the cube root of numbers. So I'm going to choose numbers who have a nice cube root. For example, I can use -8 because, as you may recall just a moment ago, we found that -8 is just -2 to the third power. So I'm going to choose -8 for my table. I'm also going to choose -1 because we did that problem a moment ago. I'm going to choose 0. I'm going to choose 1. And I'm going to choose 8 because we did all of these problems a minute ago and I already know the answers. -8, if I want to know the third root of -8, well, so I have that y equals the third root of -8. Well, I know, because I did it just a moment ago, that it's -2 because I know that -2 times -2 times -2 equals -8. So the cube root of -8 is -2. Same with -1. The cube root of -1 is -1. I know because I did that just a moment ago, right here. The cube root of 0 is 0, because of course 0 times 0 times 0 equals 0. The cube root of 1 is 1, because 1 times 1 times 1 is 1. And the cube root of 8 is 2, because we did that one just a moment ago. 2 times 2 times 2 is 8. If I graph these points, I have the point -8, -2 right here, -1, -1, 0, 0, 1, 1, and 8, 2. If I connect these dots, I get a graph that looks like this. Now once again, look here at the graphs on problems 5 and 6. First off, did you notice when we wrote these tables that the tables are very similar? All we did was switch the x and y. Once again, these two functions are what we call inverses. And we can find inverses doing this exact switch x and y trick that we did today. We're going to talk more about inverses later, but for right now you just need to know that these are inverses and notice what it does to the graph. Look at how the graphs are very similar, just kind of turned on their sides. All right, well, that is this assignment, function family cheat sheet. You are not going to be turning this assignment in now, but you will definitely want to hold on to this because this will be your cheat sheet that we're going to reference throughout the year. And when I call for notebook checks at the end of this term, this page will be part of your notebook check. So put it away in a safe place where it won't get lost and hang on to it because you're going to be referencing it throughout the school year.